Hi, this is Sugin Bhartia and welcome to TFR Newsroom. If you look at cloud, storage is one of the most critical pieces of cloud infrastructure, and the demand and the capacity is only going to grow. In 2017, Rancher Labs announced Longhorn. It's an open source project to kind of meet the growing demand for a block storage solution, which was open source, easy to manage, and also affordable. Later, they contributed the project to CNC F, and today, Rancher has announced the general availability of Longhorn. And we have with us once again Shang Liang, co-founder and CEO of Rancher Labs. Shang, first of all, thanks for coming to the show once again.
Thank you. Thanks for the opportunity.
Talk a bit about Longhorn. What is the project all about?
As you mentioned earlier, we've been working on Longhorn for quite a while. Actually, Longhorn is a project that's almost as old as our company itself. We pretty much started right after we started the company because we knew storage is going to be a critically important piece once you kind of solve some of the more fundamental, container orchestration and management problems. And over the years, storage just took a long time to get right. I think we initially launched the Longhorn project in 2017. Then last year, we actually contributed Longhorn into CNC F. It's a sandbox project, so that tremendously stimulated its growth. And storage is also one of these areas that's not as one simple solution or single solution for all use cases. So we've been working with leading storage vendors like NetApp, like EMC, like Pure Storage, and those storage solutions work very well with Kubernetes. We also been working very closely with the software-defined storage or container-native storage providers like Portworx, StorageOS, and OpenEBS. Those are all great partners of Rancher. But with all of that, we still find an opportunity to. There's still demand for a open source and low cost and very easy to deploy, easy to use storage solution that people can just run and use with Rancher out of the box. So, and that's what we envision the role that Longhorn plays.
If you look at open source world, we have Ceph, but when you look at storage, you have blocks, we have file, you have object. So what was the pressing need that you saw despite the availability of all these open source projects that you were like, we should do something? And that's why you created Longhorn.
The container industry really created a new opportunity for us to look at storage a little bit differently. So there are great solutions like Ceph and Gluster that have been available for virtualization for many years, and there's really no reason not that you can't use these solutions with your Kubernetes clusters. But we felt just the complexity of those solutions are not exactly necessary for a pure, cloud native microservices based environment. So we were able to really take a fresh look at what's really required to run, stateful workload on Kubernetes. And it basically boils down to very good block storage support. It's sort of equivalent to Amazon's EBS or VMware's vSAN. So that kind of equivalent functionality is what a large class of stateful workloads need, like workloads like databases, for example. So we kind of centered a Longhorn design for those kind of use cases, whereas a solution like Ceph is actually a lot broader. Ceph with one product does block storage, they do object storage, and it does file storage. Obviously with power, it comes with a very high degree of complexity as well. So Rancher is Longhorn is very simple. It's just I think it was just 40,000 lines of Golang code. So we had the basically luxury of taking advantage of lot of developments in the Linux storage ecosystem. We leverage a lot of Linux native capabilities like sparse files in how we do over provisioning. We leverage a lot of Linux existing storage stack in Linux iSCSI system to just dramatically simplify what we actually have to build to come to a high performance storage system. But last but probably the most importantly, we also leverage the Kubernetes itself as a microservices framework to manage Longhorn as a set of microservices. So basically, in that sense, Longhorn isn't just built for Kubernetes, but it's almost built by Kubernetes. It's built to be an integral part of Kubernetes, and coupled with that, being very open, being open source. I think it kind of addresses a need that the larger Kubernetes ecosystem has today. We would love to see more and more stateful workload moving on to Kubernetes. We love to see all these other solutions, whether they're storage systems or storage hardware or other open source, closed source, software-defined solutions, all be very successful. But I think Longhorn, for nothing else, can perhaps be one of the first persistent storage technologies a lot of Kubernetes users can use before they maybe some of them will eventually move on to to some more even more sophisticated systems. So I think that's the role we envision Longhorn to play.
You mentioned container storage. I want to understand a bit about container storage itself and why does it matter so much now?
Yeah, I think this naturally comes with the adoption of Kubernetes. So we see it matter in a number of places. One is just the workload itself. Early on, containers and Kubernetes were largely used for probably non-mission critical stateless workload, and even in the mission critical deployments, the type of workload they powered were web servers and or simple business logic, where these things don't itself carry a lot of state. So and very naturally, as the adoption of Kubernetes continues to grow, now we are seeing a very rich ISV ecosystem, not just the type of software that people develop in-house, but also the software components they use, components like Elasticsearch, like MongoDB. Just by definition, these are stateful workloads, and it's very important in order to run these type of workload on Kubernetes. You want to make sure that this fundamental enterprise grade persistent storage support in Kubernetes. So, and then there's one other angle that we're seeing a lot of demand for persistent storage in general, and also Longhorn in particular, which is edge computing. We have last year in addition to contributing Longhorn to CNC F, I'm sure a lot of you have heard about a project called K3S, and that has really made Kubernetes very popular in edge deployments. So when you are in an edge computing scenario, you don't really have access to traditional storage arrays or sophisticated cloud storage solutions like EBS. So in those cases, but you still want to run some of the stateful workload. You want to a lot of the edge computing workloads are performed to ingest the data, process the data, then output some kind of a result. So being able to store data and process data is paramount. And that's where we see a lot of adoption of technologies like Longhorn as well.
Yeah, I remember when we talked about K3s last time. It's a super lightweight distribution. So is Longhorn also kind of optimized for? You did mention, of course, edge computers, so it does mean. But is it like suitable for specific use cases, or it can be used like Linux can be used literally anywhere? So talk about that. The kind of workloads ideal for Longhorn.
Yeah, Longhorn is general purpose block storage. There are areas of storage solutions that Longhorn doesn't address. Longhorn is not highly scalable secondary storage. Like Longhorn is not S3. For those, you might want to use a cloud hosted object store solution, or you use a software solution like MinIO, right? But Longhorn is useful when you want to run transactional workload, stateful workload that require basically a disk to be persisted independent of the container itself. So in the situations where the container runs, then the container terminates or the container crashes. The container goes away, but you want that data to remain, and data in the sense of in the sense of a disk or a file system. So that's kind of really what Longhorn is about, and it roughly corresponds to traditional or mainstream block storage solutions like AWS EBS or vSphere vSAN.
As you already mentioned, there are a lot of players. The market is also growing, and there are a lot of open source solutions. Now we have this one more solution. First of all, I like when people use when we talk about multi-cloud, hybrid cloud, they use a mix of different technologies. So in terms of Longhorn, also, can they mix their block storage as well, or is totally you have to only use this? I want to understand the multi-cloud story here.
Infrastructure layer today pretty much already support some form of persistent storage. I mean, it is mostly table stakes today. Other than I'd say in the edge computing scenario, or you have bare metal provisioning. Like if these days, if you get a cloud instance on Amazon or on DigitalOcean, on Google, they all get you can all get persistent storage support. So in that sense, we still find some demand for Longhorn. So I kind of give you an example. I think the benefit that Longhorn has in providing portable block storage across multiple clouds or across multiple data centers or multiple availability zones inside the cloud turned out to be still useful. So last year I met a Longhorn user at KubeCon, and he kind of told me a pretty interesting use case. He uses EKS, which actually replicates Kubernetes cluster across multiple availability zones. But so EKS cluster is by design spread across multiple AWS availability zones. So if you lose an availability zone at its entirety, really the Kubernetes cluster will stay up. But then he had a problem because even on EKS, the persistent storage is actually implemented using EBS, but then EBS is only tied to a particular availability zone. So when you lose an availability zone that the EBS volume resides in, you essentially would have lost that persistent storage, and that's where he found Longhorn to be useful. So that's an example of actually he had Longhorn providing additional replication on top of EBS across multiple availability zones. So now he gets, with a Longhorn volume, he gets a volume that's actually resilient across individual zone failures, just like the whole EKS cluster is. So that's kind of a good example of just Longhorn adds value and work in conjunction with some of the cloud native, storage services. I mean, obviously, you can also imagine Longhorn volumes can potentially be replicated across multiple cloud providers or in a hybrid cloud deployment scenario. Lastly, Longhorn actually has a pretty interesting feature because we really see multi-cloud, multi-cluster being more and more common. So with Longhorn, we created a feature to actually remotely replicate a Kubernetes volume across potentially a wide area network into another Kubernetes cluster. So it's like asynchronous storage volume replication with defined RTO and RPO. So once you can do that, you could imagine people can use that to implement disaster recovery strategy. They can use that to implement extremely high availability. So here are some of the examples on how Longhorn would interact with other type of storage, as well as how Longhorn would actually function in a multi-cloud hybrid cloud scenario.
You guys do a lot of open source. There is an open source project that people can engage with, and then there's something which is based on those projects, which is commercial offering. You mentioned high availability, and so sometimes people do expect, depending on 5 nines, 4 nines, whatever they want, and then the SLAs. So is there any commercial offering also around Longhorn from Rancher? And if it is there, how will you kind of adhere to those kind of SLAs, or what are you kind of promising or committing to users?
With the Longhorn technology going GA, now Rancher is able to provide commercial support for it. So we're selling an enterprise subscription that allows our customers to get support for Longhorn software from Rancher. And in that scenario, obviously, the customers will be running the software, but if they have any issue with the software, Rancher would be able to provide help, troubleshooting, root cause analysis, assistance in upgrade to basically make sure that the Longhorn can actually power the customer's mission critical workload.
So how does it fit into the other offering that are already from Rancher? Will all these components be available independently, or it's like a kind of they can get the whole package from like Rancher? Because you guys are doing so much work in cloud native space.
Generally, when Rancher integrates new technologies, like when we integrated new technologies like Istio, it actually come as part of the Rancher subscription. Storage is actually a bit harder because as we all know, it's the demand on storage is a lot more stringent on just a solution that's not quite in the data path 724. So with Longhorn, we're actually creating additional SKU. So any Rancher customer, if they also want us to support Longhorn, they buy a additional subscription. It's like an add-on on top of Rancher. We still try to make it very affordable, and I think it's just still a great way to get started with persistent storage, production grade persistent storage with Kubernetes.
And it's in CNC F sandbox. What does really mean for the maturity of project? Because a lot of projects that go into CNC F, they are already being used in production. You are contributing a project so as to grow the ecosystem around it, so that a lot of other companies, even your competitors, should be able to use the projects freely without worrying about you taking the code away. So that is the basic idea. But does it really matter that, okay, it is sandbox, it's GA, or it really doesn't really matter because the maturity curve of the project has already reached?
I think that's a very good point. In some senses, storage technology is very hard. It takes many years for storage technologies to mature, and CNCF is really more of a governance. It's a set of rules that that these projects have to obey. And also it's really more about IP ownership. We as part of donating this project to CNCF, we give up on the name Longhorn. We give up on the logo, the websites, all the IP we've put into the code. So now that's all owned by a neutral body, and that's actually quite important if you think if a project like Longhorn ever can have any chance of getting industry-wide support. It doesn't just become a rancher thing. I think being in CNCF is being owned by CNCF is very important, and we see a lot of positive signs already. There's actually another very good, highly related a storage project in CNCF called OpenEBS. And we're big fans of OpenEBS, and they actually add a lot of value even on top of what these basic storage software like Longhorn can do. But one interesting aspect of OpenEBS is they use they support multiple storage engines, and I think one of the first one and also the most mature one is actually Longhorn itself, which they call Jiva, but it's actually the Longhorn code base, and we're very happy to see that. You see how this whole mutual this vendor neutral ownership of this technology is already stimulated industry-wide adoption of Longhorn technology and collaboration.
Once again, Shang, thank you for taking time out and sitting down with me today to talk about Longhorn. I was looking forward to actually seeing you in person, but that is not possible right now. So once again, thank you.
Likewise. Thanks.